Materials. Today we are going to discuss about the automated production lines. So let's get into this video. Automated production line is a system that uses the automation system for the transferring or the production process. So these are all the trending system that is recently used in all the industries to increase their production rate and profit. So this is an example of a fixed automation. It is generally difficult to alter the sequence and content of the processing operation once the line is built, because if the system is made decided to automated, it is to be completely changed and huge amount of money is required. So decision should be made clear whether we produce a system or a products through automated system or a manual system. So what are the applications of this system? It is used where high product demand or requiring high production quantities is required, and it involves a stable product design. Frequent design changes are difficult to accommodate because it is previously pre-programmed, so we cannot able to accurately or we can change the design of the product is not suitable for this fixed automation. And long product life, it lasts for several years and multiple operations are performed once we perform or programmed in it. So what is the fundamentals of automated production line? It consists of a multiple workstations or workstations such as the drilling, milling machines. These machines are called as a workstations that are linked together by a work handling system. Work handling system such as handling system, automated handling system. If a drilling process is finished, the work pieces are collected and going to the next system, that is milling or reaming, etc. And the transferred parts from one station to the next. This is an example of an inline production system. The starting parts that are arriving from the beginning is machined in the processing automation station 1, and then to the station 2, then station 3, then up to last station. In these stations, the workpieces are raw materials are processed. Finally, we can get the completed parts at the end of the line. The features of the APL are the raw work part enters one end and we get the product at the other end. The line may include inspection stations to perform the intermediate quality check, and manual stations may also be located for the beginners can be used to learn how to operate if an error occurs in it, and work handling systems can also be made in between. Multiple parts are processed simultaneously on the line, and in the simplest form of APL, the number of parts on the line at any moment is equal to the number of workstations. Each part will be under the workstation, so that the interval between the between machines is very minimal, so that the processing lead time will also be minimum. Provision is made for the temporary part storage between stations. Then palletized transfer line. The term palletized transfer line uses the pallets in the workstations or the transfer systems. The pallet fixture is a work holding device that is designed to fixture or to hold the workpiece in its correct position, so that it can be machined under the workstation. It can be moved, located and accurately clamped in position at successive workstations by the transfer system. The part is accurately positioned relative to the processing operation performed at the station. When pallet fixtures are used, as means must be provided for them to be delivered back to the front. This we can see in this diagram. These include a palletized stations, palletized workpieces. The workpieces are held in the pallets. The pallets are moved around and then washed, and finally it is comes to the beginning stage where it comes from that. This is an example of a palletized fixtures. Then free transfer line. The alternate method of work part location is to simply index the parts themselves from station to station, and that is bringing the part to the drilling station and then bringing the part to the milling station, separate station by manually. Then system configuration. There are basically a three system configuration present, that is inline, segmented inline and rotary. Inline is almost a straight line, that is raw materials are entered in one end and the product are obtained at the other end. For example, this is an example of an inline system. Segmented inline is that where the space is short or small, we cannot able to set up an inline system. So in that case, we set up an segmented inline system. Example, it is a perpendicular system where it is of 90-degree, that is L shaped or U shaped, etc. So that we can use inline system in systems which have a small or minimum amount of space. So what are the advantages? Available floor space may limit the length of the line. It allows reorientation of the workpiece, that is, if you want to machine one side of the workpiece and then we want to machine other side of the workpiece, it will revolve around at a new shape, so that it will automatically turn to the other face so that we can machine at an ease. And then the rectangular layout enables the return of the work holding fixtures to the front of the line for reuse. If we use the rectangular fixture at the one end, we can able to get from the U-shaped turn at the end. In this also, starting parts entered, processing under the workstation and inspected. Finally, the parts or products come out of the end. This is a rectangular layout where a fixture is placed. It is moved throughout the rectangular and finally comes to a position where it is entered. Then rotary configuration. In this rotary configuration, the work parts are attached to the fixtures around the periphery of a circular work table. The fixtures are attached to the circular work table, where the working stations are in the circular manner so that it can machine, and the table is indexed to present the parts to the workstations for processing. The workpieces must be indexed, or that is positioned in a correct manner, so that it will be exactly at below the workstation to machine, so that we can perform an accurate machining process. Then the work table is often referred to as a dial, and the equipment is called a dial indexing machine. So this is a dial indexing machine. The starting parts revolve around a circular manner while the products are machined in the stations such as drilling, milling, reaming, etc. and inspected. Then finally the products are come out from the side where we have inserted into it. There may be also a work part transfer mechanism. The work part transfer mechanism moves the parts between stations on the APL, and mechanism used on automated production lines are synchronous, asynchronous, and advantages of the asynchronous are greater flexibility, fewer pallet fixtures are required, and easier to rearrange or expand. In this rotary table, fewer pallet fixtures are required, that is for example 7 or 8. The pallet fixtures that you used are come to the position, it comes in a cycle, so that no more pallet fixtures are required. This is the advantage of the asynchronous transfer system. The work part transfer system mechanism are two types: linear transport and rotary transport. The linear includes the belt conveyor or chain driven conveyor and cart on truck conveyors, and rotary indexing mechanisms uses a Geneva mechanism. In inline, they use a chain or a belt conveyor where a tension wheel are present over the belt. The fixtures are present to hold the workpieces so that it can transfer the workpieces from one workstation to the another, so that we can transfer the parts between stations. There also a present mechanism called walking beam transfer that uses a transferring beam that is lifting up and down and the forward motion, so that can lift lift the workpieces from one position or one workstation to the another. In this, there are two beams. First one is fixed station beam, second one is a transfer beam. The work parts are lifted in the transfer beam and moves forward and comes down, and moves up, moves forward, comes down. In this manner they are used to transfer the work parts between the stations. Then rotary mechanism. They use a Geneva mechanism and counter mechanism for the rotary mechanism. Geneva mechanism includes, it uses a continuously rotating driver to index the table through a partial rotation. This is a formula for using this, and each indexing angle is 60°. The formula is theta is equal to 360 by ns. Ns is number of slots in Geneva. This is the Geneva mechanism, 6 slotted. When the driver causes a one rotation, it will move to the one position, so that 6 rotation of the driver is needed to complete a single rotation of the Geneva wheel, and this is the formula, Tc is equal to 1 by n. And another is called cam drive mechanism. This is the most accurate mechanism for the indexing or moving workpiece between the workstations, where uses a cam and index plate for this purpose. So this is a short video, friends. If you like this video, put a thumbs up and share this video to your friends to gain knowledge, and don't forget to subscribe this channel for more videos. So thank you for watching.